Hello everyone. In this video we are going to talk about the distance equals rate times the time using the rational expressions. Okay. Now I have an example here. But before we do, we have to understand, Okay, I'm going to write this. So distance equals to rate times the time. Okay. So in this problem, that the one thing that we're going to have to be careful here is that if you flying airplane, if you go with the wind, then you gain speed. If you go up against the wind, then you're going to lose speed. Okay. So that's the key idea here. So a pilot flies at 630 miles with a tailwind of 35 miles per hour. Against the wind, he only flies 455 miles in the same amount of time. Find the rate of the plane in still air. So we're going to call this X is the speed of plane in still air. So I suggest that you make some kind of a box. You're probably going to need this here, so I'm going to make a box here. Okay, pardon my drawing here. Okay. So I'm going to write distance, okay, rate, and the time. Okay, now this box over here, the first row is going to be with wind. And the second row is going to be against the wind. Okay, against the wind. So now we're going to fill the information. And now remember, D is equal to RT. Okay. Now the question says the going over there and coming back here is the same amount of time. So we can say that T going over there is equal to T coming back. So I guess the going over there is going to be with the wind. And the coming back will be against the wind. Okay. All right. So when you go with the wind, you go 630 miles. Okay. Now, we don't know what the X is. That's the speed of the airplane. But we do know that if you go with the wind, you pick up 35 miles per hour. So if you go with the wind, then whatever the airplane speed is, then we're going to gain 35 miles per hour wind speed. Now, when you're coming back, okay, you're coming back 455 miles. And because you're coming against the wind, you're losing your speed by wind speed. So that means that plane speed minus 35. That's how much you're losing because you are going against the wind. Now remember, T, time is going to be D over R here. Okay, distance over rate. So I'm going to write that here. Let me use other color here. So that means we have a 630 divided by X plus 35. Then we got 455 over X minus 35. Now, but we know that the time it took, right, to going over there and coming back is the same time. So we're going to have to equate this. 630 over x plus 35 is equal to, that's the going over there with the wind. Then that's the same amount of time, 455 over x minus 35. So that's coming back against the wind. Okay. Now here we can use the relation proportion. So we're going to cross multiply because we got one term on the left and one term on the right. So we got 630 times the x minus 35 equals to, we have a 435 times x plus 35. Okay, so let's multiply these out. So we got 630x, okay, minus, okay, you got 630 times 35 here, second. Okay, so 630 times 35, I got minus 22050. Now you got 435x plus, you got 435 times 35. I have, let's see, oh, you got, hang on, let me just make sure that, okay, so I have 15225, okay. Now I'm going to isolate the x, so I'm going to subtract the 435x on both sides here, and minus 435x. Okay, let's find out what that is. 630 minus 435, I get 195x minus 22050 is equal to 15225. Let me bring this over to the other side here. So I'm going to come over here. Okay. So now I'm going to add 2250 on both sides here. Let me just do that. 22050, 22050. So that means I have 195x equals to 22050 plus 15225. I have a 37275. Now we're going to divide by 195. So the x is going to be equal to, divided by 195. I have about 191.15 miles per hour. Okay. Now this kind of makes sense though, because now if you that's going to be the plane speed in still air. Now unless I made a mistake, that looks fine to me. Okay. Let me just make sure that I did this correctly. The calculation, 630 times 35, I got 2212. Oh, I made a mistake here. So I'm going to go back. 630 times 35. Oops, why am I getting different line? 630 times 35. 22050. Okay. 435 times 35, I get 15225. Now that looks fine. Okay, so 15225 plus 22050, 37275 divided by 195. So you get about 192 miles per hour. So if you go again with the wind, then there will be 191 plus 35 miles an hour. So you get 226 miles per hour. If you go against the wind, they're going to have to subtract 35 miles per hour, so that would be around 157, I think. Hang on. So minus 35, about 157 miles per hour. Okay, because the wind is going to be 35 miles per hour. So this is going to be the typical case of gaining speed and losing speed by the direction of the wind. Or you can also talk about same kind of problem using going upstream and the downstream when you're riding a boat. Okay, if you go upstream, you lose speed because the current is pushing you back. If you are coming down, then you are coming with the current, so current's going to push you down faster. Okay, so that's kind of similar to the with the wind against the wind. Okay, if you have the problem that don't have like one rational expression of the left and right, then you cannot use the ratio proportion like the way we just did here. So if you have like 630 over x plus 35 plus 1, that means that you're going to have to put them into the one fractions like this. Then once you have a one fraction on the left and one fraction on the right, then you can cross multiply using ratio proportions. Okay, so I just want to make sure that you're not going to make the kind of mistake. All right, so thanks for watching. I'll see you in the next video.